So we have to determine whether this series is absolutely convergent or conditionally convergent. So the first thing we want to do is check for absolute convergence. We check for absolute convergence first because absolute convergence implies convergence. However, if absolute convergence fails by us finding that it diverges during the absolute convergence test, then we still have to check for convergence or divergence because it may still be conditionally convergent. Okay, that sounded confusing, but it made sense. It makes perfect sense, and I'm going to show you. Okay, so first, we must remember that if we have a series, a sub n, and then another series, which is the absolute value, then the absolute value would imply absolute convergence. So we have the absolute value test. The absolute value test is one in which we take the absolute value of our series. So what would be the absolute value of our series? This would be -1 to the power of n over 5n plus 1. So the absolute value version of that series would be 1 over 5n plus 1. That's the actual absolute value of our series. Now that we have this, we can try to find out if this converges or diverges by using some test. So what test are you going to use? You're probably going to use the limit comparison test. The limit comparison test to find out if this converges or diverges. So with the limit comparison test, we have two series. We have one with a sub n and we have one with b sub n. The one with b sub n is the one we choose. And a sub n is the same one. So this would be 1 over 5n plus 1. And by the way, we can do this for the reason that a sub n and b sub n are greater than or equal to 0 for all n. That's the reason we can do this, okay? And b sub n is the one we pick, so we can pick anything that we know what's going to happen to it. So I pick 1 over n because I know what's going to happen to 1 over n, and that's like the simplified version of this. That's like the cleansed and purified version of 1 over 5n plus 1. You remove the 5 being multiplied and you remove the addition of 1, and you get this harmonic series, and we know what's going to happen to that one. So that's the one that we choose for our b sub n. So now we use the limit comparison test. So the limit comparison test, we have a sub n over b sub n. We take the limit as n approaches infinity, and if this does not equal 0 or infinity, then whatever happens to b sub n also happens to a sub n. So we know what happens to 1 over n, but let's go ahead and do this. So we would have the limit as n approaches infinity of 1 over 5n plus 1 over 1 over n. We multiply by the reciprocal, and we would get the limit as n approaches infinity of n over 5n plus 1. And so then we could divide everything by n, and we would get 1 over 5 plus 1 over n. Now we can plug infinity wherever we have an n. We only have it in one place, and this would give us 1/5 because this goes to 0. So this is 1/5. And 1/5 is obviously not 0 or infinity. So it is the case that whatever happens to this one also happens to this one. What happens to this one? Well, p equals 1. P equals 1, and if p is less than or equal to 1, then it diverges. It diverges. So this diverges, and because we use the limit comparison test, this also diverges. But remember, we're doing the absolute value. So this only implies that it doesn't absolutely converge. It doesn't actually imply that this entire thing diverges, just that it doesn't absolutely converge. Now we have to find out if maybe it conditionally converges or if it does diverge. So we've just ruled out absolute convergence. So now let's do that. How do we do that? Well, we're going to need another kind of test on this one. And now without taking the absolute value. So what test would we use? We would probably use the alternating series test because we have an alternating portion. So with an alternating series test, we have b sub n, and then we have some alternating portion like this, or maybe like this. And b sub n has to be greater than or equal to 0 for all n, and it is. So we're going to use the alternating series test. What does the alternating series test tell us? It has two conditions. The first one is that this must be decreasing. B sub n must be decreasing. Decreasing B sub n. And the other is that if we take the limit as n approaches infinity of B sub n, then that must equal 0. And if both of these conditions are met, then this converges. That's what it tells us. So we're going to do that. We're going to check. Is it decreasing? What is our B sub n? B sub n is just the portion without the alternating part. So this would be 1 over 5n plus 1. 1 over 5n plus 1 is decreasing, in fact, because we're plugging in values that are greater and greater each time, so the denominator is getting larger. That means it's decreasing. What if we plug in infinity wherever we have an n? Is it 0? Yes, because we plug infinity into a denominator, that gives us 0, because we have 1 in the numerator. So, yes, it met both of these, so it converges. But remember, we showed on the first trial that we had this go through that it doesn't absolutely converge, because we took the absolute value and it didn't absolutely converge. So that means that it must conditionally converge, because when we took the absolute value, that diverged. So we still had to go to step 2, in which we don't take the absolute value and just use another test on this one, on the entire thing, and without, absolute valuing it. So that means that this conditionally converges. Our series conditionally converges.